So we've been spending a lot of time with measurement and significant figures and getting that data into the data table, recorded in proper numbers of sig figs. But what happens when you have to take the next step, and that is doing math with all those measurements? So when you do math with significant figures, there's actually two rules that you need to keep in mind. For chemistry, most of the time it's the multiplication and division rule because we do so much dimensional analysis and unit conversion. But there's also a rule for addition and subtraction. So I want to give you each rule and then give you a couple of examples. It's really pretty easy once you see an example or two. So the rule for multiplication and division is to really, you want to count the number of sig figs in each number. So count the sig figs in all your values. And then you're going to round your answer off to the fewest number of sig figs. So the fewest number of sig figs. Looks like my pen is dying. Great. So example would be, so I pull another pen out. An example would be if I'm going to multiply 6.93 by 0.62 by 9.348. Okay, if I multiply all three of those numbers together, pull out my calculator. Sorry. So I get a number that is 4.01646168. Up until now, you might have written all those digits. Well, don't do that anymore. Now that you know about significant figures, we're going to use these rules. Okay, so the idea is you don't want your answer to be more accurate than the numbers that went into creating it. And so when you do multiplication and division, you look to see how many digits you have, and then you round off to the fewest number. So this one has 3, this one has 2, remember leading zeros don't count, and this one has 4. So I'm limited to 2 digits in my answer. So I'm going to round this number off to just 4.0. I don't round up because that's a 1. If this were 4.06, then I could say it was 4.1. I would round up, but I don't in this case. Okay, same thing holds true if I do division. If I have 7.25 divided by 1.5, okay, what's my answer going to be? 7.25 divided by 1.5, I wind up with 4.8333, repeating and so forth. But I don't want my answer to be any more accurate than the numbers that went into creating the measurements. So I've got 3 sig figs here, but I only have 2 there. So my answer can only have 2. And it's complete coincidence that I have 2 in both of them. It's just because that's the numbers. So if I did another example, 0.01604 times 2.83 times 7.905. Okay, if we do that math, who knows where those numbers came from? Of course, I'm just making it up. Sorry, I typed in a number wrong there. So I wind up with 0.358833246. Way too many digits. So now I got to go and count. I've got, that one doesn't count. 1, 2, 3, 4 here, only 3 here, and 4 here. So my answer can only have 3. So 0.35, not 8, I've got to round up to 9. Okay, so that's multiplication and division. You round off to the fewest number of sig figs. For addition and subtraction, it's a different rule. So what you're going to do is you're going to round to the lowest common decimal place. Again, because your answer can't be any more accurate than the numbers that went into making it. So if you have a measurement that stops at the 10th place, but two others that go beyond that, the 10th is the last for sure digit known to all of them. That's where you have to round. So for example, if I've got 7.346 plus 0.29 plus 83.067, if I add those up, I wind up with 90.703. Okay, so now all the numbers can have a ones place. This one doesn't, but it's more sensitive, so this one must be able to count. They all have a value in the tenths place. They all have a value in the hundredths place, but this number stops at the hundredths place. So my answer has to stop at the hundredths place. So 90.70 is what my answer can be. Okay, so don't get multiplication and addition mixed up, because this one I actually wind up having more digits, more sig figs than that one, because I'm finding a common decimal place. I'm not counting numbers of sig figs. And the same is going to hold true if I do subtraction. 9,648.3 minus 268 gives me, stick it in my calculator quick, 9,380.3, but look where my answer is. This guy doesn't go to the tenths place, so my answer has to get stopped here. So 9380, does that 0 count? Is that significant? It does. So I would need to put a decimal point there to make sure that that was properly labeled as a measured value, a significant figure. All right, so you've got a couple of problems to take a look at. You've got to think about rounding. Where am I going to round things? As well as the two rules.